When I was in my early school days, I had a misconception that male and female voices are different only because male vocal cord is thicker, producing lower pitch, and female vocal cords are thinner, producing higher pitch. But recently I realized something surprising. If a man and woman sing the same musical note, say E scale, the pitch is exactly the same for both, yet their voices still sound different. Why? Because of harmonics. Welcome to Unai Science. Today we'll discuss harmonics. A vocal cord behaves somewhat like a vibrating string of a musical instrument, such as guitar, violin, tanpura, fixed at both ends. When a string vibrates, it does not vibrate in just one single pattern. Instead, several vibration patterns can occur simultaneously. The string can vibrate in one segment, two segments, three segments, four segments, and so on. If the fundamental frequency is 82 Hz, the same string also produces vibrations at 164 Hz, 246 Hz, 328 Hz, etc.
So, can a single string vibrate at many frequencies at the same time?
Yes, those additional frequencies are called harmonics or overtones. They're simply the integers of fundamental, that is multiples of 82 Hz.
That's very confusing. Okay, consider a point A on the string. At a particular instant, the point will be in two different positions. How that can be possible?
Okay, that is a genuine confusion. Fact is, the string vibrates with the summation frequency of all the frequencies. At every instant, the actual displacement of the string is simply the sum of all the individual vibration patterns. This is principle of superposition.
Okay, that is understandable, that the string vibrates at summation of frequencies. But when I vibrate a string with a particular frequency, how and why other frequencies, its harmonics, are generated along with it?
Okay, for that you have to understand the superposition theory of weights. When you pluck a string, the pull is felt along the entire length. When the weights up pull reaches the fixed ends, it cannot continue. The fixed boundary reflects the weights pass back along the string. The weights back and forth from both ends continuously overlap. That is why all the harmonics of the fundamental are created, and this phenomenon is called superposition. Now, what makes a man and woman sound different even if they're singing the same pitch? Well, usually, male vocal cord is little thicker than female vocal cord. See, amplitude decreases as harmonic order increases, but the thin string produces bigger amplitude in the higher harmonics relative to thick string. So here in female voices, the higher harmonics drop off less steeply. That's why male voice sound heavy, deep, warm, and female voice sound bright, sharp, and ringy.
So, what happens between two male or two females?
Actually, not only the thickness of cord, the shape of throat, mouth, nasal cavity, tongue, lips, these all shapes act like filters that reduces some amplitude and boosts up some amplitude, and you already do it without even knowing. I think the basic concept of what makes voices sound different, the basics of harmonics, how they are produced is clear so far. If you guys like my channel, please subscribe, stay in touch. See you in my next video. Bye-bye.